Hello again, everyone. It's Mr. Anderson. Today we're going to talk about material from Chapter 4, our Solving Systems unit, but specifically we're going to focus in on Section 4.1.2, where we build on writing equations and move into doing some solving. Two problems today that we're going to focus on, and they do require a little bit of reading and understanding, and specifically reading carefully for understanding. And I've got them highlighted in our notes, so you can follow along, obviously on my notes, but you can also pull these from your CPM ebook. These are going to be problems 4-20 and 4-21, and like I said, they do come from section 4.1.2. But we spent some time in prior lessons from 4.1.1 talking about how we could write expressions and turn those expressions into equations. And the purpose, of course, is for the opportunity to solve, right? It really makes us a very powerful problem solver if we can write an equation that models a problem and then solve it. Today, we're going to go ahead and focus on writing a couple different equations, and then we're going to use this thing called the equal values method that CPM has coined. I'll show you what I'm talking about. It's right here. The equal values method, and it's this idea of substitution. Really, maybe you've seen this before, but let's go ahead and without further ado, let's dive into problem 4-20. So I'll read, and again, if you got to pause and reread, go ahead and do so, because understanding what's happening in the problem is going to arguably be the most important first step that we have before we can tackle writing and solving. So here we go. Elise took all of her cans and bottles from home to the recycling plant. The number of cans was one more than 4 times the number of bottles. She earned 12 cents for each bottle and 10 cents for each can, and then ended up earning $2.18 in all. How many cans and bottles did she recycle? So first thing I'm going to point out is there's two things that we're gonna get after here. We're being asked in the question how many cans, how many bottles. We're going to be solving for both of those things, and because of this, we're going to need two variables, or we're going to need a single equation written with one variable relative to the other, and we'll kind of check out both options and see which one lends itself to the more convenient solution or more convenient solving opportunity. Solomon decided to solve the problem, by writing one equation. So Solomon's going to go one equation, and if he's going to solve, he can only have one variable. Let's look at that. He says I can let B be the number of bottles, and then 4 times B plus 1 would be the number of cans. My equation would look like this. Okay, check this out. 12B plus 10 times 4 plus B plus 1 equals 218. Okay, now before I go ahead and read what Marcus said, I'm going to go down here and tackle part A with you. It says Solomon's equation has 3 terms: the 12b plus, the 10 times 4 plus 4b plus 1, and then the 218. This right here, right, the 12b, because he gets 12 cents for each bottle, this is the money, the money from bottles. Okay, and then he's got 10 times 4b plus 1. This right here is going to be the money that he or she Elise, it's a she makes from cans. And the reason we know that is because she's making 10 cents for the cans, and she's got 4 times the number of bottles plus 1 more. So 4b plus 1 represents the cans. So we've got the rate, 10 cents per cans, multiplied by the number of cans. That's going to give us the money she makes from cans. And then this piece right here, this 218, this is the number of cents total. All right, and typically we'd write that as $2.18, and of course $2.18 is the exact same thing as 218 cents. All right, so being clear about what each one of those terms are is kind of important. All right, Marcus then, and I'll change my pen color here. Marcus, I'll back up and reread this blurb about Marcus. Marcus agreed with Solomon's answer, but said it's easier to solve the problem with 2 equations. So Marcus is going to take a different approach. He says, I can let B represent the number of bottles and C represent the number of cans. And he says that way, my 2 equations are C equals 4b plus 1, and 12b plus 10c equals 218. What do each parts of Marcus's equation represent? Well, let's talk about this one first. C equals 4b plus 1. That is the number of cans. C for cans is 4 times the number of bottles plus 1. Okay, so he's going to take whatever that bottle number is, he's going to multiply it by 4, he's going to add one more, and he knows that's how many cans he's got. But then this piece right here, this second equation, right, because Marcus has 2 equations. All right, he's got 12b, 12 cents times the number of bottles. That's going to give him the money that he's making from bottles. And then 10c, he's adding that to it. 10c is going to be the number of cents that he pulls from all those cans, 10 cents per can. And then that's equal to 218 cents total. So effectively, they have some very, very similar approaches, and that hopefully should ring true and maybe give you a sense of security because they're both working on the exact same problem. All right. Do Solomon's and Marcus's equations represent the same problem? Yes, of course they absolutely do. I'll point this out, try to make this part very, very clear. Look at this. They both have 12 cents multiplied by the number of bottles. They both have 10 cents multiplied by the number of cans, and they both have a 218 cent total, right? That's important. It says they're working with the exact same problem involving a lease. Now here is where maybe you can make one final connection that's going to help you out. Okay, look at this. All right, see this 4b plus 1? The slight difference, now Marcus wrote it in 2 equations, but the slight difference is Solomon, when he did it, put it in the first equation. He wrote C relative to B. And if you have that skill and if you have that opportunity and convenience, you can definitely do that, right? We're going to see as we move forward into this unit, we're going to see that doing something like this with 2 equations might lend itself a little bit differently to graphing. Maybe if only I needed to do, the only thing I need to do was solve, I might just go with 1 equation. But maybe if I want to graph, maybe 2 is the better option, right? There are certain opportunities that are going to present themselves as advantage for 1 or 2. Okay. Part D says, solve this problem using Solomon's equation. Be sure to label your answer. You do not need to solve Marcus's equation, okay? I remind you that Solomon's equation is going to be 12b plus 10 times 4b plus 1 equals 218. So let's go ahead and use our rules of algebra to solve this thing. I'm going to zoom in and give us maybe a little more space. If you need to pause and do some solving here, you can definitely do that. All right, I'm not going to touch this 12b yet, but I am going to distribute this 10, right? If you need to, write that generic rectangle out. It ends up being 40b plus 10 more, and that's equal to 218. Now I think it's a wise move to combine these like terms, 12b and 40b. That makes 52b for us, and 10 more. And finally, the right-hand side still hasn't changed. We've still got 218 over there. Now we're simply going to go ahead and subtract 10 from both sides to isolate that b variable. And that gives us 52b equals 218 minus 10 is 208. And then the last thing we do is divide by 52, and you might have beaten me here with your calculator. We've got b equals 4. Okay? And what does that tell us? That tells us, that tells us that the number of bottles, right? We want to communicate effectively here. Number of bottles is 4. Okay? But the other thing we really should find out is, what is our number of cans? Remember, if you back all the way up to what Elise said, the number of cans is going to be 4 times the number of bottles plus 1 more, which works out to be 17 cans. Okay, so we really got 2 answers there. It's one of those things that we're going to continue to see more and more. Okay, moving on to the next question. Renard thought writing 2 equations was easy, but he's not sure if he knows how to solve. So we're going to spend a little bit more time with another opportunity to solve, and we'll talk about what this equal values method shows us. Okay, check it out. Reading and understanding. Ariel bought several bags of caramel candy and taffy. The number of bags of taffy was 5 more than the number of bags of caramels. Taffy weighs 8 ounces each and caramel weighs 16 ounces each. The total weight of the bags is 400 ounces. How many bags of candy did she buy? All right, let me grab blue here. Renard says T is going to be the number of bags of taffy. C is equal to the number of bags of caramel. T for taffy, C for caramel. That's pretty common. Help him write 2 equations. Well, the number of bags of taffy was 5 more than the number of caramel. So the first thing I can do is say taffy equals the number of bags of caramel plus 5. That's going to be pretty straightforward. Okay, the second equation I'm going to involve is going to be keyed on all of these rates, and they all include the exact same unit, ounces. So I'm going to say 8 times the number of bags of taffy and plus, right, we're adding to that, 16 times the number of bags of caramel equals 400. So there's my 2 equations, and what we can do is we can use a little equal value method, substitution, and we can do some solving here in a second, right? Now Renard is stuck. I'm moving on to B. Now Renard is stuck. He says if both equations were in the form of T something, I could set the 2 equations equal. Help him change the equations. Well, this one's already done, but this second one, 8T plus 16C equals 400, is not. So let's go ahead and help Renard out. I'm going to subtract 16C from both sides, and then I get 8T equals negative 16C, which is, plus 400. And now let's just divide everything by 8 to isolate that T variable. And when I do that, I'm sorry for my spacing here, I get T is equal to negative 16 divided by 8 is negative 2C, and then 400 divided by 8 is 50. So now I've got 2 equations with T by itself on the left-hand side. Okay, now check this out. This is where the equal values method comes in. If I can go ahead and set those up like that using each equation, I can now set those parts equal to each other, right? Because they're both equal to T. Okay, this comes from right there. Let's use a different color, Anderson. This comes from right here, this part, and then this part comes from right there. Okay, and folks, now we just use those simple rules of algebra. I will subtract 5 from both sides, and then I will add 2C to both sides, and then I'll simply divide by 3. 45 divided by 3 is 15. So what does that tell us? It tells us she's got 15 bags of caramel. Okay, but now what can we do? Well, we can use either one of our other equations to figure out how many bags of taffy she bought, and I'm going to select this one right here. I'm going to say, well, I know that T equals C plus 5, so if C is 15, the number of bags of caramel she bought is 15, the taffy is going to equal 15 and 5 more, and everybody here can do 15 and 5 more, which is 20, okay? So, if you stop here and you write T equals 20, I'm sorry, I might be a little off the screen there. Let me correct that. Sorry about that. If you just write T equals 20 and C equals 15, yeah, of course you got it. But I would love to see a sentence here. Like, hey, what was the gal's name again? Ariel. Ariel bought 15 bags of caramel and 20 bags of taffy. That would be so awesome, right? Communicating at that high level. Now here is the last part, and we're going to discuss this, and we're going to verify that this works. All right. It says discuss how you can make sure this is correct. Well, you can plug it back in and evaluate. Okay. Remember, we were given the information that each bag of taffy weighs 8 ounces. And each bag of caramel weighs 16 ounces. So we can check and make sure that works out to 400 ounces. All right, I'll leave this to you guys. If you plug in 20 for the taffy and you plug in 5 for the caramels, does that work out to be 400? Check that out and verify. If it does, you're doing all right. You should also check the other one. Okay, ladies and gentlemen, one last thing before you're done today, right? 3 review preview problems. They're in our CPM ebook, 25 to 27. Remember, if you scroll all the way down till you find that wonderful review preview logo, you see 25, 26, and 27. Don't forget to check your answers, use your homework help, and ask for questions. Folks, thanks for watching. Have a great day.